Welcome to Eureka Math. I'm Mr. Shankel. Going to be helping you today with Module 4, Lesson 27. Let's get started. Our job is to determine the nature of the solution to each system of linear equations. So we can do that before we actually solve it, and we're going to do that as well. But first we can determine the nature just by taking a look at the two equations in slope-intercept form. So right now I'm good on the second equation, but this first one I need to fix. So I'm gonna change this 3x plus 4y equals 5 into slope-intercept form. That means I need to subtract 3x from both sides. And that gives me 4y equals a negative 3x plus 5. And then I'm going to multiply by the reciprocal of 4 to get the y isolated. That means I'm multiplying this entire expression by 1/4. It looks like I wrote 1/2 there. That's 1/4. And then here's what happens. The 4's cancel. I get y is equal to a negative 1, this is 8 times. 1/4 times negative 3 is a negative 3/4 x. And 5 times 1/4 is 5/4, so that's a positive 5/4. Okay, so now we have the two equations in slope-intercept form. Let me write the other one down here. Negative 3/4 x plus 1. So here is our system of equations. And here's what I see. I notice that the slopes are the same. And if the slopes are the same, it means that either they're parallel lines or it's the exact same line. So then I look at my y-intercept and I see the first y-intercept is 5/4, 1 1/4, and my second y-intercept is a plus 1. So they definitely cross the y-axis at different points, but they're parallel. So these are parallel lines, I know, just by looking at the slope-intercept form. Same slopes, so they're going to have the same tilt, and then they cross at different places. They cross the y-axis at different places. So these are parallel lines. They will never intersect, so there's no solution. So they're parallel, and that means that there is no solution. Okay? Well, let's see what happens when we actually solve these two equations. So here's what I see. It tells me that y is equal to negative 3/4 plus 5/4, negative 3/4 x plus 5/4, and y is also equal to negative 3/4 x plus 1. If y equals both things, then these two must be equal to each other. So I can take these two and say that negative 3/4 x plus 5/4 is equal to the other expression, negative 3/4 x plus 1. And that has to be true because they are both equal to y, and y is equal to y, so they have to be equal to each other. So now I want to simplify. I want to get all of my variables on the same side. So when I do that, I'm going to add 3/4 x to both sides. And when I add 3/4 x to both sides, it cancels on the left side. I get 5/4 is equal to, and it cancels on the right side, and that's equal to 1. Since 5/4 does not equal 1, I know that this system has no solution. No solution. So even when we solve this system by setting them equal using substitution, I can see that there is no solution. 5/4 does not equal 1. All right, let's keep going. Number 2. I want to put these in slope-intercept form first. So 7x plus 2y equals negative 4. I'm going to subtract 7x from both sides. And we get 2y is equal to negative 7x minus 4. And then multiply by the reciprocal of 2 on both sides. And let's see, that gives us y is equal to And when I multiply through here by 1/2 times -7 is -7/2 x, and 1/2 times -4 is a -2. So there's my first equation in slope-intercept form. And then let's do the other one. The other one is x minus y equals 5, and I want to subtract x from both sides. I get a negative y is equal to a negative x plus 5. And then I know that the opposite of y is y, and that will equal the opposite of my expression. That's a positive x and a negative 5. So y equals x minus 5. Okay, and then when I look for the slope, I see that the first slope is a -7/2. The second slope is a 1, right? That coefficient of x is a 1. And they cross at different places on the y-axis. So I know that these two lines are going to intersect in one specific place. I know there's one solution here. There is one unique solution. And I can find that by solving the system. So let's go ahead and solve the system. I know that since y is equal to -7/2 x minus 2, I can say -7/2 x minus 2 is equal to the other one that's equal to y is x minus 5. Since y is both of those, they're equal to each other. So x minus 5 on that side. All right, now I can get all of my variables on the same side, so let's work on that. Let's call this 2 over 2x. So then I can add 7/2 x to both sides, add 7/2 x, and that cancels on the left side. I get -2 is equal to 2/2 plus 7/2 is 9/2 x minus 5. And then I can isolate for the x. So that's what I'm going to go to work on. I'm going to try to get x all by itself by adding 5 to both sides. That gives me 3 is equal to 9/2 x. And then I can multiply by reciprocal. So I'm going to multiply by 2/9 on both sides, 2/9. And let's see, on the right side, my 2's cancel, my 9's cancel, I get x equals, and on the right side, I can simplify before I multiply. 3 goes into 3, ooh, I moved that. 3 goes into 3 one time, 3 goes into 9 3 times, so my answer is 2/3. When x equals 2/3, then I can figure out what my y is equal to. And so I can use either equation. I can use any equation, either before I changed it to slope-intercept form, or if I changed it afterwards. So I'm going to use one that looks the easiest. I'm going to use this one. Y equals x minus 5. So let's use that. Y equals x minus 5. And I know that x, I'm going to substitute. I know that x equals 2/3. So this is 2/3 minus 5, which would be 15/3. And then I can simplify. Y is equal to 2 minus 15 is a -13/3. So the ordered pair that will make both of these equations true is 2/3 for the x value and a -13/3 for the y value. One unique solution. And I knew that just by looking at the slope-intercept form of the line. All right, let's do another one. We have 9x plus 6y equals 3, and 3x plus 2y equals 1. So our job first is to change these to slope-intercept form. 9x plus 6y equals 3. Subtract 9x from both sides. We get 6y equals -9x plus 3. And then multiply by the reciprocal of 6. That's 1/6. Multiply the right side by 1/6. And so we get y equals -9/6. That's negative 3 halves, if I simplify it, x. And then a 3 times 1/6 is 3/6, that's 1/2 simplified. So y equals negative 3 halves x plus 1/2. That's the first equation in slope-intercept form. Second equation in slope-intercept form, we would take 3x plus 2y equals 1. Subtract 3x from both sides. And we get 2y equals negative 3x plus 1. And then multiply by the reciprocal of 2. And multiply this expression by the reciprocal of 2. And here's what we get. Y equals 1/2 times negative 3 is negative 3 halves x. And 1/2 times 1 is 1/2. All right, so I look at my two equations. Y equals negative 3 halves x plus 1/2. And y equals negative 3 halves x plus 1/2. And they're exactly the same. They have the same slope. They have the same y-intercept. These two lines are exactly the same line. So that tells me that there are infinite number of possibilities, infinite number of ordered pairs that will make both of these true. Since they're the same line, they're going to share all of the same points. All right, and I can prove that just by using substitution. I can say, well, this expression, negative 3 halves x plus 1/2, is equal to y, which is this expression, negative 3 halves x plus 1/2. And when I say that, it's like saying 5 equals 5, or 2 equals 2, or 10 equals 10. It equals itself. So no matter what, even if I try to solve it, which I will, I'll add 3 halves x to both sides because I want to get my variables on the same side. If I do that, the x's cancel. I get 1/2 is equal to, the x's cancel, I get 1/2. 1/2 is equal to 1/2. That's true. If I could put anything in for x and it would equal itself. So I know this is true. It's always true. They are exactly the same line, and there are infinitely many. So I'm going to say infinitely many solutions. I can't name them all. All right? Let's check out another one. All right, number 4. We're doing the same thing. So let me just change these to slope-intercept form. 3x plus 3y equals negative 21. Equals negative 21. Okay, and then I'm going to subtract 3x from both sides. And we get 3y equals negative 3x minus 21. And then I'm going to multiply by the reciprocal of 3. That's 1/3. And multiply by 1/3. All right, so we get this. Y equals 1/3 times negative 3 is a negative 3/3. That's a negative 1x, so negative 1x. And then negative 21 divided by 3 is a negative 7. So y equals negative x minus 7 is the first equation in slope-intercept form. And the second one, let's see what we get there. The second one is x plus y equals negative 7. X plus y equals negative 7. And if I subtract x from both sides, that gives me y equals negative x minus 7. Same equation, same slope, same y-intercept, same line. These are the same lines, so it's infinitely many solutions. And then we can graph them both. We can say that, well, it crosses at negative 7. 1, 2, 3, 4, 5, 6, 7. Crosses here. And the slope is down 1, right 1. So it's there. And then I could draw that line, which would be right through here. Let's get that in the right spot. Okay, right there. So there's our line. That's the first one. And the second one's the exact same line. So you can notice that every possible point I chose along this line would be on both lines, and that means there are infinitely many solutions. I can't make enough dots along this line, and it continues forever in both directions. So infinitely many solutions to number 4. Okay, if I were to solve this algebraically, which it does ask us to do, it's just going to say that negative x minus 7 is equal to negative x minus 7. And when I try to get all of my x's on the same side, they all go away, and I get negative 7 is equal to negative 7. And that's true. It's always true. And that means that there are infinitely many points. All right. Let's do another one. Number 5. Slope-intercept form. I don't have to change that one. That's nice. But I do have to change 3y equals x plus 2. Not a great deal, but a little bit. Multiply by reciprocal. Multiply by reciprocal. So we're going to multiply here. And what we get is y equals 1/3 x plus 2/3. 1/3 times 2 is 2/3. So y equals 1/3 x plus 2/3, and our original, the first equation was y equals 3/2 x minus 1. Different slopes, different y-intercepts. These two lines are going to intersect each other. They're not parallel. They're not the same line. They're going to intersect each other, and there's going to be one answer. So I can solve this algebraically by just saying that the two expressions equal each other. Let me show you which ones. It's the 3/2 x minus 1. 3/2 x minus 1 is equal to 1/3 x plus 2/3. 1/3 x plus 2/3. And they're equal to each other because they're both equal to y. And if they're both equal to y, then they equal each other. So now I can, first I need a common denominator. So I'm going to change these denominators into sixth. 3/2 would be 9/6. So I'm going to write 9/6 x minus 1 is equal to, and 1/3 changed into a 6. So I don't have to multiply by 2 over 2. That's 2/6 x plus 2/3. And now I can subtract and get all of my x's on the same side. So I'm going to subtract 2/6 x from both sides. And when I do that, 9 minus 2 is 7/6 x minus 1 is equal to 2/3. Okay, and then I'm going to isolate the variable. So I'm going to get to work on getting that x all all by itself. So I'm going to add 1. And when I add 1, I'm going to add 3/3 so that I can do that to the right side. 2/3 plus 3/3 is 5/3. So it goes away here. I get 7/6 x is equal to 5/3. And then I'm going to multiply by the reciprocal of 7/6. And if I multiply by 6/7 on both sides, that will tell me what x is. X is, let's see. I can simplify before I multiply, so I'm going to do that. 3 goes into 3 once. 3 goes into 6 2 times. And then I can multiply 5 times 2, that's 10, over 1 times 7, that's 7. So x is 10/7. And now I can plug that in to either equation. Doesn't matter which one. I'll choose this top one. And I can solve for y. Y equals 3/2 x. Well, I know x is 10/7, so times 10/7 minus 1. And that's equal to y. That's how I'm going to find y. So let's simplify. Let's simplify before we multiply. Let me change colors so you can see that happen. 2 goes into 2 once. 2 goes into 10 5 times. So 3 times 5 is 15/7 minus 1, which is 7/7. So y is equal to 15 minus 7 is 8/7. And that's my ordered pair. The x value is 10/7, and the y value is 8/7. That's where these two lines will intersect, which produces the only point that belongs to both lines is at that intersection, and it's right here, 10/7, 8/7. All right, that is lesson 27. Hope that helps. See you again next time.